Well, welcome. We're going to talk about a practical guide. I guess it would help if I turn this back on. Practical guide to Fedora, chapters 5 through 8. We're going to start out talking about the command line. Okay? How does it work? Pretty simple. You start out, get the first word and save it on the command line, right? Come to our new line. Do we need to get more information for that command line? Yes or no? We don't? Let's continue on. Does that program exist? If it does, execute it. If it doesn't, can't display anything, right? So then it issues you a prompt saying, hey, I can't find anything. Start all the way back up. Pretty simple, right? If I'm typing something and it exists, it'll do what it tells you to do. If not, it'll tell me, try again. Get the big red X like on Family Feud, right? Roger got that one. Thanks, Roger. I agree with you. We have 3 forms of standards in Linux. We have what we call a standard input, a standard output, and a standard error. Okay? We just described those in this screen. We have our standard input. We input it in this new line. It gives us an output. It'll execute that program that would be an output, right? Or it's going to error. I'm going to tell you to turn off the lights. You either will do it, or you'll say, what? I didn't hear you. Correct? So, what? I didn't hear you is even though it's an output, is a form of an error because you didn't compute what I told you to do. Pretty self-explanatory, right? So what you have is you have your standard input. What are you going to do? That's what we call a command. We put it into this command or into the shell. The shell then determines it. Is it an error or is it an output? Did they catch that fly ball? If so, we have a out. Else we have an error, right? It hits their glove and falls off. I know these 4 guys here in the back really know what I'm talking about. I can't tell you how many baseball times we've talked. So we get this wonderful little thing. By default, your standard input is going to come from a keyboard, okay? Now, you can also eventually later on, we'll talk here in a couple minutes, about how you get an input from a file. Okay? Y'all have written Java programs or Python programs to input source code, right? You're taking that source code, that's your input. Comes through the shell to that command line. The command line interprets it, and then we'll either output it back or give you an error, one or the other. I like to call it the T. All right? Here we go. We can have a standard input, comes to the command. Standard output. Not only can it be displayed on the screen, it can be displayed in the file. It can just be displayed on a printer. How else can we display it? How else can you display data? Well, you have a screen. We said screen. We said printer. Sound. Thank you. Right? Music. Video. What did I say? You can take a file and input it. And it will deliver a standard output, right? Take the file. Let's put it in to this command line. This command line will interpret it, do what it tells it to do, and gives you an output. Unless you have a compiler error, then you'll have a what? Speak up.
Error.
What kind of error? Standard error, right? Pretty simple concept. You know how long it took my summer class to learn this concept? 2 days. It's pretty easy. Now let's talk about chapter 6. Chapter 5 is all about standard input and output and error. Y'all got those 3 pretty easy, right? We have a 1, a 0, and a -1, which we'll talk about a little bit later on. A family tree. Y'all are familiar with seeing family trees, right? Start with your grandparents, your aunts, uncles, your mom or your dad. Then you have your sister, brother, and you, and then your kids and your grandkids, right? Lineage. What is this terminology? It's a directory tree structure, right? Family tree, directory tree. Kind of makes sense, right? What about if you're a secretary? They have correspondence. They have personal correspondence, business correspondence, and memos. Underneath business, they have milk company and cheese company. Under milk company, they may have sent a couple letters, right? What is this? It's a secretary's tree structure. So, in reality, what you have in your circles are going to be your directories. Files will be in a rectangle. Thank you. So as you go down, you can see, you can make this as big as you want or as small as you want, all right? Y'all understand directory tree structures. Y'all should if y'all have had NetAdmin, if you've had networking, if you've had any PC-based class like macro hardware. This chapter ought to be very easy for you. In Linux, you're going to have something very similar to this, which will have the root directory, but I'll talk about that more later on. You have your /home, your /etc. What are those? Those are what we call absolute paths, because they tell you exactly where that is. Under root, the home directory. Under root, the etc directory. Under root, under home, under HLS. That's where that is. Does that make sense?
Yes.
If you spell it out, it is an absolute path. We also have terms called relative paths. But before we get to that, think of it as an absolute path like a MAC address. Is there any other MAC address the same? No. It is an absolute. What about an IP address? They call those logical addresses, right? Because there can be multiple with the same IP address, especially if you're doing NAT or private IP addressing, right? So let's get to relative path. If I wanted to get from here back up to here, what do I have to hit? If I hit dot, it goes back to my working directory. From command line, I hit period, enter. So from report, I go back down to HLS. If I hit dot dot, I go back to home. Or you can just say cd space / and you're there. Okay? That's relative, because you're relative to where you were at. So if I'm at Zach and I want to go back up here, I can do dot dot / Zach and it takes me right back to the home directory. Does that make sense? I'm sorry. From the home directory, if I do dot dot / Zach, it'll take me down to here. Or I can just do cd space Zach. Those are relative paths. Remember, if you use dots, you got relative. Otherwise, you're absolute. Yes?
If you wanted to go all the way to the root directory, dot /
You can do dot dot /.
just dot / right?
Because it's easier just to do cd space / because you'll always go back. Dot dot only takes you to the previous level up. So if from home, yes, it'd be dot dot / to take you back up to there. If you're down here, you got to do cd space /.
Do you go back so far?
You can go back. All you're doing is moving around in the directories.
Okay.
Just remember, if you have any dots, it's relative path. So if I give you a quiz and say, what, and I say, give you an absolute path and say, is this a relative path? You need to know that it's relative or absolute. If I give you the full directory, that's an absolute. If I have a dot anywhere in there, it's an absolute, or it's a relative.
It's relative.
Yes. Because it's relative to your position at where you're located.
Okay.
So if I'm at bin and I go dot, what am I doing?
You just go back to HLS. Gotcha.
One dot, one directory. Two dots, two directories. Okay? Makes sense?
Makes sense.
Two directories down or whatever. If I'm going from here, coming down, I got to go dot dot / Zach, or I can just say /Zach and go right to it because I'm already in home. But if I'm up here, I need to go dot dot / Zach because it'll be below that. Relative to where you're at is how you type it in. If you're above it, you have to type in basically the absolute. If you're below it, you can type relative. Easy way to differentiate. Okay, file structure is developed in examples. We have our root directory, which is not root's home directory. You need to keep those separate. Okay? We have home. What is home directory? That's where my documents, or my user. User S. Stokely. That's be user S. Stokely. That make sense? Underneath there, I have all my different types of directories or files. And I can keep doing directories under directories under directories. Remember, you can only go out 256 characters, right? From root out 256 characters, that's as long as a file name as you can have. Remember that. If I want to move files, I use the MB or the move. So I can say move names and move temps under the literature. Or if you're really lazy, go under the GUI and just drag and drop, right? But from command line, you use the move command, MOVE, or MV, or MV names to MV literature, or slash literature slash names. So it moves it, or just slash literature. So it'll move that directory underneath there. All right? Here is a typical Linux file system. You have your root directory, you're going to have a bin, an SBN, a var, a dev, or for your development, users, etc., temp, home directories, and then my root. This is root's home. Make sense? Slash root is the root's home directory, not just root. I know, so when I say root, I'm referring to this. If I say slash root, or root's home directory. Remember, root's home directory is a step under root. Okay, when you do your ls-a command, and you're listing all the requirements or specifications for a file, this is what you're going to see. You're going to see the type of file. In this case, there is no type. We have RWX, RWX, RWX. Then we have our ACL flag, which we'll get more into a little bit later on. Links. You're going to either have a hard link or a symbolic link, which we'll get to a little bit later on. The owner of the file, in this case, Sam owns this, right? The user that owns it. If this file is in a group. Let's say Sam was in the pubs, logged in underneath the pubs group, or gave permission to this file to the pubs group.
Like the home group?
Yeah, it could be the home group. Because the pubs, I'm assuming this is publications. Okay? So anyone that has pubs in this group has read and execute only. Remember, you have owner, group, other. That's what RWX is for. And we'll get to that a little bit later on. The size tells you the file size, the date that it was created, and the time it was created, and then finally the file name. Pretty simple, right? So if I tell you to find me something that's been hard linked, where are you going to look? You'll look at links, but there's also going to be some numbers out here that'll tell you it's been hard linked too. Okay? Links. All a link does is cross-classify, which means if I have a symbolic link, I have created a document over here that is now linked to document B somewhere in document B. So if I delete document B, A still exists, right? Because it's symbolic. It's just pointing to it. Let's say I'm pointing to a paragraph or a specific page in a PDF file A from PDF file B. I'm pointing to it. You have your, better yet, let's do it this way. We have our cylinder, right, on a hard drive. Making this oversimplistic. All right. We have file A. Right? Let's say whatever was here, there was something there when this file was created. So let's skip that section, right? Y'all remember this from micro hardware? So when you have your master boot record, we'll point to file. It's going to say this one, here, and here. Make sense? So we have file A. We know we have file A. Now if I wanted to put B1 as part of this file as just a link, it's linked into this file, right? That tracer or that link to that file, that's a symbolic link. Just because I erase this link, does that mean that file has gone away? No, it's there until it's been overwritten, right? Now we also have what we call a hard link. A hard link is when you have these files and they're all interconnected. So this would be A-3. A hard link means they're all together so that if A3 gets deleted, all of it gets deleted. You delete it in one location, you delete it in another. So if I have a hard drive that's on a RAID system, right? RAID 0, it's a mirrored system. If I delete it on this one, is it going to delete it on this one? RAID 0, yes, because it's a mirror. Or what? I'm sorry, RAID 1's the mirror. RAID 1 is the mirror because you draw the line and it gives you the mirror. That's how I remember it. So you have your mirrored image, right? If you delete it over here, it deletes it over here. That's a hard link. Picture that for your hard link. Picture RAID 0 for striping for symbolic link. Just because I deleted on hard drive A doesn't mean B and C, it's deleted. Does that make sense?
Which one is that one you just explained?
RAID 0, that's a striping. That would be the symbolic. Because it is in multiple locations. Until it gets overwritten, it's still there.
Okay, that's symbolic.
Does that make a little more sense to y'all?
Yep.
Explaining the difference between a hard link and a soft link or a symbolic link? And all you're doing is, in this case, we have symbolic link. We have a directory for personnel, memos, and business. A symbolic link is a shortcut in Windows. Does that make it a lot easier for you? Just because I delete that shortcut did not delete my file. If I move that file to the desktop and I delete it, then it's deleted. That's a hard link. All right? We have two links to the same file. Under root, home, Max and Zach have a shared file. Both link to this one file. Okay? So you could have home, Max, we'll call it letter, and then Zach, draft. They could be two different directories underneath two different things pointing to the same file.
Okay.
The main file could be located underneath Max's directory of letter, but Zach under draft has a shortcut. That's a symbolic link. Yes, no.
Yeah, it is. It is. It is.
Evan?
Yeah, I'm following.
You don't follow? Okay. A shortcut on your Windows desktop. If it's deleted, is the file gone? That's a symbolic link. Because you're taking a symbol and putting it in its place. If I move that file to the desktop and delete it, that is a hard link because it has deleted the file. That's all it's saying. In this instance, Max under home, Max in this area right here would be letter, but under Zach it's called draft. They're two different directories. I have the same file. So if we're sharing a file under home group on our NAS storage device, you delete it, and it's a hard file, I lose access. If I have the hard file myself, and you just have a shortcut on your area of the NAS, and you delete it, I still have the file, you just don't have access to it anymore.
Right.
That's a symbolic link.
Right.
Any more explanations?
Well, it's
Yes,
a
Roger.
little unclear on how, I understand how they can have the two different directories, Max and Zach, pointing to the same file.
Uh-huh.
I don't understand how they can point to the same file with a different file name for each.
Okay,
directory.
these aren't different file names. These right here are actually directories. Because this
It's a
is,
square.
oh, well, yeah, it is a square. They did. He could have it as a draft, but you can. I'm trying to find the best way to describe it. Have you ever done a? Have you taken Java? When you did a, what's the terminology? a typecasting. You typecast a string to an integer to get the ASCII value. Same idea. He's just typecasting draft over the name of the letter. It's just a symbolic link. It's bad drawing. You should still have them separate and say this file and this file they need the same so you can actually see it a lot easier. So what they're really trying to say is you have max and this one we'll call it. We had draft and we call it letters, right? Or letter. This is what they're really trying to say. They just put the wrong symbol on there.
So
But
if either one of those modifies that file,
they both still have the modification.
they both see the same changes.
Right, just like Google Docs. Multiple people can have access to that file and be doing it simultaneous. It still saves it as that.
Is that how like databases and access?
Exactly. And that's all it is. Let's talk about chapter 7. Y'all's favorite chapter, BI. I absolutely hate this chapter. Don't ever use it after this lab, okay?
That's what lab 5 is asking, right?
Huh?
That's what lab 5?
Yeah.
That's what's asking. Supposed to use that.
Oh, it's telling you to use it. It's so you can be familiarized with it.
Okay.
After this, use Nano or gedit.
Okay.
Okay? Starting Vim. VI, whatever your file name is. Or you can just say VI. If you do just VI, you're going to get this screen right here.
Yeah. Yeah.
Or VI letters. If there is no file name letters, then it will give you the same screen. But if you have a VI letters, it is going to create you letters. Or open up letters. Does that make sense?
VI space letter.
Yeah, VI space letters. So in this case, starting it without a file name, all we did, this is what you're going to see. Tell you go into the insert mode, which is, how do you get into the insert mode?
Alright.
All opposed?
Oh. Very good.
Darn. At least someone got it. All right. The modes in VI, very easy. To get into input mode, hit escape. From the input mode, you hit escape. Get you to command mode. Click colon, gets you to the last line. Actually, this is a little strange. You want to see what they're trying to say here?
It's supposed to be command line.
Yeah,
Yeah, 2 Z's, right? Was it 2 capital Z's?
Z's save it.
Yeah, QW. QW is quitting to write.
Seems like pictures are not their forte.
This person did not do a very good job on explaining this. That's why I hate Vim. It's so complicated. Okay, if you're not sure whether Vim is in the input mode, press the escape key. Here's the easy way to find out if you're in the input mode. Does it say insert? Okay? If it is, then you hit escape and then colon. And that gives you to your ability to enter command. Okay? Escape gets you to command mode. Colon gets you to command line. Do y'all make sense? So in this kit, we did a Vim for help. Don't ever do this. Just do man help. It's a lot easier. Because all this is a text file. Put Vim back in input mode. To get it into input mode, you put an I. Then escape, and then colon, and WQ, exclamation point, you know. That's why I hate Vim. But here's the thing with Vim. It was created as the first inline text editor there is for Linux. At the time, that was all they had, so it was easy to deal with. Now we have a lot more functionality that we're used to, right? With Nano and gedit. Here's Nano. This makes it a lot easier, doesn't it? Because you have your control keys. Control X, Control G, Control O for write. You know. Nano, whatever your file name is. Or just hit Nano. Type in Nano, and that'll bring you to open Nano. Okay? Nano Practice 2. Y'all done that, right? Lab 5, Lab 6.
Lab 9.
Is it Nano's 9?
I had a problem with it. I had to ask you about it.
Okay. And then to change the file name, you do your colon, file name to write, change your file name right here, you enter, you changed your file name. Or from command line copy file name, you change it to whatever file name, right? This is their version of how the internet works. I'm not going to explain it because this is outside the scope of this class. This is pretty bad drawing. Here, let me explain the internet to you. My way. You have your LAN, you have a router, connected to lots more routers. That's the internet. Don't need to make it even more simple than that. Okay? Once you go outside your router or your gateway, you're on the internet. Which means all you're doing is you're connected to a bunch of other routers and gateways. A file server. What is a file server? Holds files. It's a big home directory. That's what a file server is. Your NAS drives, network attached storage, usually is a file server of some sort. Could be a media server, which holds media files. So thus it is a file server. And to make it easy, how many of y'all are familiar with the organization of how you get the tiers? Anyone know? Okay, you know .com.edu, .mil, .org, .net, right? Above this, they even have it wrong. You start with the dot. That's your top level domain, is dot. It's also called root. And this, baby, is the IANA. You want to kill the internet? Blow up the IANA. Serious. That's where root server, the broadcast, the DNS addresses to everyone in the world is at. From there, you get your 3 letters or your 2 letters. .us or .tx.us or whatever. .govs, .coms, .edus, .mils, .orgs, .nets. This is what we call the first level. Don't ask me why, because root is really the first level. Then you have example.com, berkeley.edu, moma.org, whatever that is. Okay? Those are second level. That would be like Microsoft.com. That's your second level. So you get to Microsoft and you go up one more level, guess what? You're in the 3 levels. How many of y'all have ever tried to search for .com? Just .com. You can't. They don't allow any searching above this level.
Because you might destroy the internet. That makes total sense.
But how many hackers have tried? Probably millions.
I don't blame you.
Now you can go up here to come back down, but they're not going to let you. There's nothing that's .gov, .com, .edu, .mil that you're allowed to get to. Then underneath this, technet.microsoft.com, msdn.microsoft.com, live.microsoft.com. Y'all catch it? And then you keep having your, this is what we call the third level. That would be your server name on your domain by your domain prefix, even though it's a suffix, by the way you read it, it is a prefix off the root level. Is there any questions on that?
No way.
We just covered 5, 6, 7, and 8. Any questions on those 4 chapters? I told you this is a fast-paced class.
No, it's up to you to do everything in between.
That's right. Any questions?